So we're going to finish off the traveling salesman with probably one of the hardest to do on it. So previously we've done the upper bound using a Kruskal's to find the minimum spanning tree and then times it by 2 to get an upper bound. We've refined it with the nearest neighbor algorithm, so we're down to 3280. And at the moment, this is my upper bound. Now I want to find the lower bound. And at IB, the way to find the lower bound is simply to delete a particular vertex and ignore that vertex deletion, and all of the things that come from it, and produce a minning span. So I'm going to go, thinking about starting in Madrid, I'm going to take away Barcelona. So this first one is take away Barcelona. So it's no longer there. And it means that none of these are there for the time being. Okay, actually I'm not going to have all those deleted out because I'm going to need them at the end. So what I'm going to do is I'm going to do the Kruskal's, which means find a minimum connector. There, 150. There, 160. The next one is 350, Barcelona to Valencia, but I'm not allowed to use any of Barcelona's 4 vertices. So after that, it's going to be 360. Then this 400. 530 connects up, 200 here, by the way, makes a loop. So I don't want any of those. So the final one is this one here, which is 610. So I've connected every single city up, apart from Barcelona. And when I've done that, I'm going to go to Barcelona and choose the 2 smallest vertices that connect me back to the graph. So I'm going to do 350 and 630. Now this doesn't actually make a nice tour. There's a bit more to do it, but this acts as the lower bound. So for Barcelona, remember I deleted Barcelona, and this gives me 2660 kilometers. So at the moment, that's my best lower bound. However, what I need to do is to do that for every city on the map. And then, once I've done that, I find the highest of the bounds, the highest number I've got, and that becomes the lower bound. So we're going to do it all over again, but this time we're going to take off Valencia. So I don't want any of these Valencia edges in my Kruskal. So same again, 150, 160. Do not want 360, do not want 350, 400. That makes a loop. 610 and 630. So I've connected every city apart from Valencia. Now I'm going to connect using my 2 shortest there. And Valencia, I think, gives me 2660 as well. So remember, I'm looking for my highest. Now I've done this with all the cities. So if you want to pause the video, you can check all the cities. I might do one more with you, and then I'll write down what it is for each city. So now I'm going to ignore Vigo at the top, and I'm going to do a spanning tree that doesn't involve Vigo. So I'm going to have start off with there, same one there, 350, 360, and then connect that one there. So that's spanning tree that doesn't involve Vigo, and now I'm going to connect Vigo using these 2 very large ones down here, like that. And with VI deleted, this came out as 2780. Now you can check these, but when I deleted Malaga, I got 2560. When I deleted Seville, I got 2230. And when I deleted Cordoba, I got 2360. And finally for Madrid. Now Madrid was the interesting one. It gave me 2920. I'm just going to double check that, 2920. So I'm going to take off Madrid because that one then looks like it's the highest one. So nothing out of Madrid means I start off with these two ones I was starting with before. I then have this 350. So I can't connect that, I can't connect that, I can't connect that. I can connect that. Now I can't connect these two. I can connect this one here. So now they're all connected around, apart from Madrid. I'm just going to double check my addition here. So I've got the 350, 570 here, 160 and 150. And that's 750. So that's 1,980. And now I've got to connect Madrid using the two smallest. So it's that one there, and that one there. And Madrid, slight mistake, Madrid has actually given me 2,740. So actually, it is Vigo, which is my highest. Now I'm able to say now that I've got my traveling salesperson problem is somewhere between here and 3280. Now the problem with the traveling salesperson, traveling sales problem, is that it doesn't give us an exact answer. We're not able to go and say that 2780 is actually the lowest point. All we know is that our best solution lies somewhere between these two. And the reason we can't get it exactly without doing various other checks is because this is a Hamiltonian graph, and there's no exact method that exists for finding the best paths on Hamiltonian graphs. One thing I will say that is important, if this is the same as this, so if your lower bound is exactly the same as your upper bound, your nearest neighbor algorithm, then you have found the optimal solution. One final thing is that IB, they probably wouldn't make you do all of these. You probably just have to do one or two as an example.